electric cars are becoming increasingly popular worldwide. They are perceived as an eco-friendly alternative to traditional combustion engine vehicles with a lower environmental impact, particularly in terms of CO2 emissions. However, behind the myth of the electric car as a green solution lies a more complex reality. One of the major emerging issues surrounding these vehicles is their recyclability, or rather, their lack thereof. So, can we really claim that an electric car cannot be recycled? Why does the recycling of electric cars remain a significant challenge? The recycling challenge of lithium-ion batteries. Lithium-ion batteries, the main component of electric cars, represent one of the biggest recycling challenges. While they provide substantial range to these vehicles, they also pose numerous difficulties due to their complex chemical composition and the presence of rare metals such as cobalt, nickel, and lithium. The recycling of these batteries primarily involves two steps: battery discharge and component dismantling. However, the recycling rate remains relatively low, largely due to the complexity of the required processes and the lack of adequate infrastructure for handling this type of waste. Although solutions are being developed, such as technologies aimed at recovering valuable materials from batteries for reuse, they are not yet sufficiently effective or widely accessible. Beyond batteries, the challenge of recycling electric vehicles. Beyond batteries, other parts of an electric car, such as the body, motors, and electronic components, also pose recyclability challenges. Like their combustion engine counterparts, electric vehicles are made of various materials, including aluminum, steel, plastic, and glass. While these materials are indeed recyclable, the real issue lies in their recovery at the end of the vehicle's life. In a traditional combustion vehicle, most metallic components can be salvaged and reused. However, electric vehicles have structural differences, mainly due to the presence of batteries and advanced electronic systems, which complicate the recycling process. Additionally, the assembly of these vehicles requires new materials that are often less known and harder to process. For example, the use of composite plastics in certain parts of the body is increasing, but their recyclability remains lower than that of traditional plastics. Electric motors, although simpler than their combustion engine counterparts, also contain rare metals and materials requiring specialized recycling processes. While induction motors used in many electric cars are easier to recycle than internal combustion engines, other technologies, such as permanent magnet motors, require recycling methods that are still underdeveloped. The lack of adequate recycling infrastructure. One of the main barriers to electric vehicle recycling is the lack of suitable infrastructure. Although efforts have been made to increase battery recycling rates through collection programs and partnerships between manufacturers and specialized companies, there is still much to be done to build effective systems on a global scale. The European Union, for instance, has implemented strict regulations to encourage vehicle recycling, including electric cars, by imposing recyclability quotas for certain materials. However, these regulations do not always cover batteries or other specific electronic components that require different treatment. Moreover, in many developing countries, electric vehicle recycling is not yet a priority, and there is no robust system in place to manage the end of life of these cars. The sustainability of the economic model. Another crucial question surrounding the rise of electric vehicles is the sustainability of the overall economic model. Currently, electric vehicle production largely follows a linear economic model: resource extraction, car manufacturing, consumption, and disposal. However, for a mobility model to be truly sustainable, it is not enough for vehicles to be clean during their use. They must also be designed for easy recycling or reuse at the end of their life. As we have seen, this is not yet the case. While the materials used in batteries and some parts of electric cars are recyclable to some extent, the reality is that the necessary technologies and infrastructures for large-scale recycling are still insufficient. This raises the question of a truly sustainable consumption model. Does the emergence of electric cars compensate for the ecological impact of their production and disposal? At present, the answer appears to be no. unless significant progress is made in waste management related to these vehicles. Despite their low CO2 emissions during use, electric cars are not exempt from environmental concerns linked to their production and recycling. Battery manufacturing in particular is resource and energy intensive. Furthermore, the extraction of rare metals needed for battery production is often associated with severe environmental and social impacts, such as ecosystem degradation and poor working conditions in mines. Rethinking the electric car model. These concerns highlight the need to rethink the consumption model of electric vehicles. Should electric cars be considered only a temporary solution for reducing greenhouse gas emissions, or should we explore more sustainable alternatives such as promoting public transportation, carpooling, or even electrifying public transport infrastructures? The recycling of electric cars is a complex challenge, but there are numerous ways to improve the situation. First, it is essential to invest in research and development of new recycling technologies, particularly for batteries. Some companies are already working on processes to more efficiently recover valuable materials from batteries, thereby reducing their environmental impact. Second, manufacturers must rethink the design of electric cars to facilitate their recycling. This means choosing more durable and recyclable materials and making vehicle components more accessible at the end of their life. For example, batteries could be designed for easy removal and recycling, and other car parts could be made from materials that are easier to recover. Finally, governments and businesses must implement more efficient and accessible recycling infrastructures. This requires not only investments in recycling facilities but also better management of electronic waste and end-of-life vehicles. In conclusion, while electric vehicles offer a solution to reduce emissions during use, their sustainability depends on major improvements in recycling methods, material recovery, and the development of a circular economy. Without these advancements, the green label associated with electric cars remains incomplete, and the environmental challenges they pose cannot be ignored.